watch the sky.
2 meters. Oh my God.
Whoa.
Oh my goodness, 2 of them.
I haven't looked around me, I haven't looked at the view. I think if I did, I would be stuck here forevermore.
Looks like the surface of the sun. It looks like all of my wildest dreams into one moment. 5 meters. 2 meters. Oh my God.
If you took in one breath, it was going to kill you.
Looks like the surface of the sun. It looks like all of my wildest dreams.
It was certainly visual heroin. God, that took from, I don't know, about 15 years, probably $1 million. I think we had roughly 25 or 30 days of bad weather, and we finally got a good weather day and we managed to get to the bottom.
The best part about this is on the way down it's all gravity. Nathan, I'm starting to move now on belay.
To be honest, I was never worried about the lava at all. Rockfall was our biggest fear of all. So if you're halfway down inside the volcano, then and it rains, you're getting rocks raining down around you that the rain has caused, as well as battery acid strength acid rain.
Trying to clear rocks. Ah, this is not good.
Yeah, kind of hell.
We're about 150 metres above the lava lake, and as you can see, we've come a long way, and it's mind-boggling. And there's the gold down there. That's the cursed lava lake that's sucked up my money for 15 years in many futile attempts to get here.
As we got down the cliff, and I realised that it was actually going to be successful, yeah, it was pretty good. And I wasn't waiting to put the suit on. I wanted to have a quick look.
5 meters. 2 meters. Oh my God. Oh Jesus. You have no idea how ridiculously small you look.
Severe radiant heat doesn't go around corners, it's like light, until you actually walked to the edge and could actually see the lava. Then you were hit by a wave of heat that was, you know, much like putting your head in a furnace, I guess. Yeah, it was beyond my wildest dreams. You could only withstand that heat for a matter of seconds before you had to turn away.
Am I close enough to the edge, Brett? I can't go any closer.
If you took in one breath of that superheated air, it was going to kill you.
I'm getting the suntan. What did it look like? Right. It looks like the surface of the sun. It looks like all of my wildest dreams into one moment.
Once I came back with the breathing apparatus and the heat suit on and everything, I was able to stay there for like 3/4 of an hour.
You wouldn't believe how hot that was. When those big pulses of lava come up, if it wasn't for the air from the breathing tanks and the heat suit, it'd probably just about kill you.
Even with the heat suit on, it's like being in an oven. 1 or 2 minutes, even with the breathing apparatus, all this stuff on. The lava's probably 30 metres away, and it's just the most incredible heat. There's nothing to describe it. Nothing on earth. It's like looking into the sun. It's kind of cool.
I still reckon that shot is one of the greatest volcano shots of all time. how many unsuccessful attempts were there before we got down? I don't know. Probably a dozen at 100 grand each. Yeah, a lot. You know, there were some crazy incidents. There was one occasion our helicopter got hijacked. Another time the boat got hijacked along with all our stuff. So it's like the Wild West. We finally ironed all those out. We finally got to the bottom. What kind of happened when we first got people to the bottom, we started taking private people who had enough money to pay to do it. That became quite successful.
So what sort of clientele do you have?
Which I can't even tell you. We've had a member of a royal family. I can't tell you any more than that. I can tell you I was pretty, how would I put it, myself, that we didn't lose you know, a member of the royal family, because I guess I'd be in hiding somewhere. Everything was going well. We were finally getting what we thought was going to be a good, viable business going on this remote island. In late December, this fissure eruption opened up on the side of Ambrym. What it actually did was that it emptied the lava lakes. There appeared to be a number of earthquakes, including a very big one. And whether the magma chamber was empty, we don't know, but for some reason the whole of Ambrym and Benbow caved in. Well, at first I didn't really believe the scale of what people were telling me. And so I went up to the island and went up there in the helicopter, and that's when we realised that as we approached the island, I realised straight away that the whole place had destroyed itself. We came, we succeeded, all in good time, of something that no longer exists, in a way that makes it even better. You know, we can truly say that we've stood on ground that no one else did and no one else ever will stand on.
It's kind of cool.
Humans are certainly not in charge of this planet. We're just, you know, at the mercy of nature.
But here in Guatemala, it's the collision of tectonic plates deep underground that plays a critical role in the team's mission. They're hoping to capture Fuego's next violent nighttime eruption. But much to the team's frustration, there's little sign that a major explosion is imminent.
Getting quite a few shots of some small eruptions. It's a case of just perseverance and keep on fishing, and one of these days we're going to catch one.
Beneath Guatemala, where two plates collide, oceanic rock meets continental rock. The oceanic rock is pushed downwards into the hot interior of the planet, where it melts. This newly created molten rock is less dense than the magma around it, and below Fuego, it slowly rises to the surface, eventually erupting.
What we're here for is some really good, large, explosive eruptions.
They could happen at any moment, or not at all.
Is that blast position, or is that where it's sitting right now?
The team knows that one clue that this big eruption is about to take place lies within the crater itself.
Slightly above the summit, looking at it from here.
Today, they are going to attempt the first part of their mission: to place a camera right on the rim of the crater to look down into its scorching heart.
Getting to see right into the crater would be amazing.
They are going to be looking for how much loose rock has accumulated and any sign of movement. This could mean a big explosive eruption is due any day. Duncan is going to use a remote-controlled camera he's built for the job. The only way to get it close enough is to lower it into position using a drone he specially adapted. It has to be powerful enough to cope with the thin air at Fuego summit, nearly 4,000 meters above sea level.
So we can test the camera.
It's the first time anyone has ever attempted this.
What we're trying to do here is completely new and innovative. We're trying to place these cameras right inside the crater of Fuego so that we can get angles that have never been seen before.
Duncan has spent 6 months designing and building the drone and crater cam.
Is this camera still good? It's very nerve-wracking because you know that if there's a blast, the aircraft gets destroyed and you can't try the experiment again.
He only has one set of kit. So if anything goes wrong, there's no second chance.
But I'm just trying to talk myself out of this because, you know, because I know the consequences. If it goes off, we lose the drone. Should we go?
Yeah, I think we just go. Okay, sounds good.
Taking off.
Duncan's crater cam is in the air. It's accompanied by 2 other drones to help him guide it into position. He wants to place the camera in exactly the right spot on the edge of the crater, so it's pointing down into it. And then get the drone away before it's destroyed by an eruption.
600 meters to go.
Duncan's drone only has 20 minutes of battery life. It's a race against time.
300 meters to go. So we're entering the blast zone now. If it goes off, yeah, we're going to be knocked out of the sky.
Yeah.
They are almost in position above the crater rim. The landing site is only a few meters wide. And if the crater cam smashes into a rock, it will be destroyed.
Okay, coming down now. Is it down?
No, pull up. You need to be closer to the crater.
Swing around.
About 3 meters closer to the crater.
Yeah. We're in the danger zone for far too long, but we need to get this camera down. Yeah. Okay, how far am I? Oh, Christ, I just hit the volcano.
You're right within the crater now. You're right above the vent.
Duncan's now drifted right above the crater itself. And the volcano could erupt at any moment.
Eruption. Rise up. RTL.
Suddenly, lumps of red-hot magma hurtle towards the drone. It's undamaged, but the battery is now nearly flat. They have to abort the mission.
Need auto.
Coming home.
They got the kit out just in time.
So where we were hovering, those huge boulders have just come out.
Yeah. How can we zoom in?
Wow, that's crazy. Yeah, if you hadn't said there was an eruption coming, we would have still been there. And there's a reason why it hasn't been done before.
This part of their mission has failed. It takes far too long to position the camera using this system. And it will take months to redesign. The challenges of trying to fly drones in such a hostile environment have suddenly become all too apparent. But even though they couldn't drop the camera on the crater, they did capture a unique view inside it. And that's given them a clue that a big eruption could be about to happen. They send up a recce drone to double check.
The crater's really full with all this material that is built up from explosions.
Yeah, a working hypothesis is that the volcano erupts much more violently when the crater is full.
With the crater this full, the big eruption the team is hoping for could be imminent. One with enough energy to blast red-hot molten boulders the size of cars hundreds of meters into the air.
I mean, look how full it is. Right?
Yeah, yeah,
all
it's
of this
really
stuff.
full.
But for that kind of large explosive eruption, another crucial factor has to come into play. The minerals in the very rock itself.
Across volcanoes around the world, we have different types of rock that makes volcanoes erupt in more explosive ways.
The mix of minerals in the rocks beneath every volcano is unique and dramatically influences how each one erupts. The final part of their mission is underway. Peter flies his drone towards the crater and starts to circle the danger zone.
Okay, you're quite close
quite
there.
close.
So you're well within the ballistic zone there.
Definitely.
Okay.
Now, all the team can do is wait.
Go on, blow, man, blow.
And hope they are in the right place at the right time.
That is extraordinary.
Wow.
Just as they had hoped, Fuego's crater ruptures. The footage reveals that rocks from this massive eruption are traveling upwards at over 100 meters per second.
That's lovely.
Isn't it?
This blast has the same force as 10 tons of high explosives being detonated, and is by far the biggest eruption the team has witnessed.
Thanks, Fuego.
As day turns to night, all their hard work and preparation are finally paying off.
Good owls.
Really good.
Over the next few hours, Fuego explodes. Not once, but again and again.
Look at that!
Look how high those ballistics are. 300 meters?
The high-definition footage shows the true size of individual molten bombs of lava.
I've never seen that much detail from an explosion like that. It is absolutely mesmerising.
It was certainly frightening when I got hit. I thought, this is really stupid, I shouldn't be here.
But you're right.
Boris!
I'm Boris, and I am a volcanologist working on Mount Etna and other Italian volcanoes. Etna is certainly one of the most active volcanoes on Earth, so Etna erupts virtually all the time. These paroxysms are characterized by the formation of huge lava fountains, many hundreds of meters, sometimes more than 1,000, 1,500 meters high. This eruption emitted approximately 100 million cubic meters of magma. What might have become a possibly threatening and destructive flank eruption became an extremely spectacular summit eruption. What was maybe a bit more outstanding this year was the sheer quantity, the sheer size of these paroxysms. They were all big. All active volcanoes are potentially dangerous. There is no safe volcano. So active volcanoes are not safe. And sometimes potentially hazardous and dangerous events can take place also in conditions where you usually would not expect them. There was this steam explosion in 2017, which involved a lot of people, including a BBC crew and yours truly. Was certainly frightening. Given the quantity of rock projectiles that came down, was how are we going to get out of this? When I got hit, I thought, okay, here we go, and thought, this is really stupid, I shouldn't be here.
But you're right.
The main problem at Etna has been the fallout of what we call pyroclastic material. Pyroclastic material is fragments of volcanic rock created by explosive activity that rips the magma when it comes to the surface into fragments. When this material falls over inhabited areas, it covers everything. Sometimes pretty gloomy scenes. You drive into that sector that has been stricken by the fallout maybe 1 hour before, and everything is black. It becomes a continuous carpet. And what happens is when this material lies on roads, the roads become slippery, almost as though this were snow. There have been deadly accidents. One thing that they do here, unfortunately, is they use these blowers. So they're blowing this material from one place to another just to remove it from a sidewalk maybe, and they create an enormous quantity of dust, including the well-known PM10 fraction, which is respirable and which can even get into your blood. And that's where problems can become more urgent. So people obviously already suffering from respiratory problems will have more trouble with that. And there is also some suspicion that long-term exposure to these very, very fine dust particles can lead to pathologies like cancer, thyroid cancer, and so on. So these are all reasons why we definitely need a system to treat this material. They have never planned for this. There is no plan for this. And you can understand that these people get really desperate. They get really, really, really sick of it. Well, we do keep our volcanoes under surveillance. We have seismographs. We can measure how volcanoes swell. We use GPS for that. We use satellite radar, strain meters, a microphone to record infrasound signals. We measure gas emissions. We measure magnetism and gravity. We have video cameras. We have thermal cameras. We use radar. So whatever can be used to capture volcanic signals is being used. And yet, it can only record the signals that the volcano is ready to give us. People ask us, with all the instruments that you have, with all those instruments, with all the money that you get, you're not capable of telling us what the volcano is going to do in the next 15 years? We can tell only things about what the volcano is going to do once the volcano tells us. It will certainly happen. It will certainly be the next serious and potentially very destructive eruption of Etna. There's no way around it. It's inevitable. There's this old Japanese saying that in the moment that everybody will have forgotten the last disaster, the next one will strike. People cannot imagine what can happen. We do not know very precisely what process creates the magma that feeds Etna. It's very, very fascinating. It's sometimes a bit confusing, and there's still a lot of mystery to it. Yeah, so how can we deal with future volcanic crises, future volcanic events? Certainly, we cannot prevent them. Certainly, the volcano is teaching us important lessons, and we need to pass them on to the people, to tell them, we need to tell them the mantra of international disaster mitigation and prevention, which is awareness and preparedness. There's a lot of work to be done there, and we do it especially with the young people, because they might be the ones that will change things.
We're losing the sun, and if we don't find a bomb soon, it's going to be too dark for Shane to see where he's running.
There is one lava bomb, I'm just monitoring it here. It's fallen just in front, it looks like, of where Shane is planning to run in. It looks like it's in the right place.
It looks perfect, actually. It's the one.
It appears to be the ideal size for Shane to be able to run in and grab.
When I get close, you just have to sort of left, right, too fast, too slow, backwards, forwards.
I'm not very good at left and right. I get them mixed up. That's why Kate's on the radio.
Thanks.
The moment has arrived.
Just check.
Check radio. Hello.
Torch is on. Okay, you ready? All right, good luck.
Yasser has gone eerily quiet.
Take care.
Shane needs to wait for the next big eruption. Then it'll be time to go.
Just watch the sky. Sun's going really high.
Wow. Oh my goodness.
Watch that.
Okay, Shane, what do you think?
I'm about ready to go in.
Okay, we'll pick you up on the camera as soon as you come off the ridge.
Righto.
After that big blast, the clock is ticking. It could be just 2 short minutes before the next eruption.
Got him? Oh yeah, okay, got him. Okay, Shane, keep heading on that trajectory. Turn right now, Shane, right now. Head straight towards the edge of the rim.
Yep, head straight there.
You're about on it, you're about on it.
Can't see it.
Shane can't spot our fresh bomb, amongst the older ones. And then it gets worse.
Shane, we can't pick you up on the thermal camera. We can't see you anymore.
Just going up to that shark one.
Shane's now completely on his own and heading for the shark fin bomb.
Have you got it, Shane?
Got it.
Be quick, Shane.
It's already been over 2 minutes. The next explosion could be any second, and the bomb is far too big to carry.
My heart is in my mouth.
Shane's managed to break a piece off,
Okay, Shane, are you coming out?
but he's still got to get out.
Come on, Shane.
You feel so exposed. Almost like you're buried inside the thing. Whoa.
Oh my goodness, 2 of them. Let's have a look.
I feel like I've had about 10 cups of coffee.
Oh, you can hear your adrenaline in your voice. Wow. Look at that. Is it still a little bit of warmth in it?
In the middle, especially. If you look at the middle, it's just amazing.
Oh my goodness, look at that.
Getting fresh.
Oh, that's incredible.
It was much, much bigger than I thought, when I got down there.
Yeah, it looked like you had to hack at it for a while. That's fantastic.
Well done. That is amazing.
I think we were really lucky with the conditions. It's just...
I didn't feel any gas probably.
Yeah, and it is so beautiful. There is just something magical about the fact that we saw that as a molten piece of rock being ejected from that crater, landing with that wonderful thwop, and here it is. Whoa. Geology is quite cool sometimes.
Yeah, it's quite fun sometimes.
We've done it. Just in time.
Oh my goodness! Quite glad you weren't down there when that was happening.
The idea of hanging over boiling lava seems more than a little crazy. But the rock and gas samples from deep within the crater are the final pieces of the puzzle Shane needs to understand what this volcano is doing.
So you're ready to be a guinea pig?
I am.
These are like dipsticks in that, they're a glass tube, and I'm going to break off the end.
Yeah.
And then during your descent and return, over that period, the gases that you encounter will react with the chemical on the foam in here. Kind of put them facing downwards so they don't get ash in them.
Okay.
And when you get back, we'll take them off and see how much gas you've been breathing.
Thank you.
Rightio, we're ready to roll.
Squeeze that lever.
Once we're clipped in, there's no turning back.
So, feet as wide apart as possible.
Yep.
That'll give you lots of balance.
We plan to abseil down this near vertical drop to a ledge above the boiling lake of lava.
Excuse me.
No, don't worry at all. We'll be doing it to each other all the time. We just smash into each other.
If we're successful, it will help give us a new insight into the inner workings of this volcano.
I have to confess that all I'm looking at the moment is my feet and Tim's feet. I haven't looked around me, I haven't looked at the view. I think if I did, I would be stuck here forevermore.
Kind of one of these steps again, one of these vertical bits.
The heat from the lake is intense, and the noxious gases mean we can't be here for long. We have to move fast, but the crumbling rock makes it difficult to get a foothold.
Lean back, feet apart, legs straight as you can. Oh, sorry. Oh, Tim, sorry.
Okay, no problem.
God, I really did bash you. Okay.
Everything we're carrying has to be tied onto us, or we'll lose it forever.
You just lost your hand for a second.
Oh, yeah. Got it. Just as well there's nobody below, otherwise we'd be knocking plenty of rocks down.
This lasts all the way down to the ledge now.
All right.
The roar of the lava boiling away drowns out everything else, and it's a truly awe-inspiring sight.
You can rest your hand on my head as you stand up if you want.
Spectacular. The sound of it's amazing. Wow. That's beautiful. You know, they often say this is the eye, you know, the Ambrym, or the eye of the volcano in the local language, but it's, to me, it looks more like the heart, you know, it's just so active, so pulsing, so alive, full of the good red stuff. Wow, it's cool. That is so cool. You know, often, you know, you think of geological processes as being old and dead processes, but this is geology in action, isn't it? Wow, it's amazing. I just try and get over there.
Shane's mission is to collect rock samples from inside the crater.
Just knock down some of that to the volcano gods.
Chris will analyse them to see if any of the newer lava is similar in composition to the lava from previous major eruptions. If so, it could mean Ambrym is heading for another big eruption.
Come on.
Are we there?
Yes, you can see it.
Finally, Tim and I reach the ledge we've been aiming for. Getting gas samples from close to the lake will give Shane clues to understand this volcano.
What we'll do is to slowly adjust these knots so you can go forward.
I don't want to go forward, I really don't. I really don't. I just... Not yet, anyway. Let me...
I've got you.
I know, but I don't want to pull you over the edge, Tim. It's just so loose, this rock.
So now what we'll do is
I'm clinging on for what feels like dear life. But to get the best samples, I have to get even closer to the edge.
You go back to your left.
They don't want me right on the edge, do they? Right on the white rock?
This right, what is it?
Yes, that way a bit more.
Centimetre by centimetre towards the white rock.
Gotta be kidding.
Wherever we can get you to will be.
Oh wow. Okay. It's sort of like witnessing the beginning of the Earth. But it's the most astonishing feeling, really, to be down the crater of a very active volcano. And these glass vials on my back that Shane put there will hopefully give him some sort of clues as how active this volcano really is at this very moment.
The conditions are intense. The gas mask keeps out most of the noxious gases, but they burn your eyes and your throat, and the heat is overwhelming. So we have to go while we've still got the strength to climb to the top.
So the great wildebeest migration in northern Tanzania is probably one of the most spectacular natural phenomena to witness in East Africa. Every year, over 1 million wildebeest, accompanied by several hundred thousands of zebras, antelopes, and of course predators that will follow along that migration path. The entire distance that this migration takes every year is over 1,000 kilometers per year. My name is Simon Kubler. I'm a geologist. Oldonyo is a very interesting and unique volcano that is located in northern Tanzania. From a tectonic, volcanic, and ecological point of view, this volcano is very interesting. Well, it's super strange. Oldonyo is the only active carbonatite volcano in the world. Carbonatite is a kind of melt that is very rich in carbonates. So it has a lot of calcium, magnesium, sodium, potassium stored in the melt. And the lava is not only chemically fascinating, it also has fascinating physiological properties. It has the coolest lava in the world. The carbonatitic lava melts at only 500 degrees, which is less than half the temperature of which other lava would normally melt. This forms a very special and very unique volcano that is, there's only one of those volcanoes in the world. I'm mostly interested in Oldonyo from the point of view of how the volcanic ash, after these explosive eruptions, influence the soils in the immediate vicinity or the wider vicinity of the volcano. So we went to northern Tanzania to analyze the interplay between volcanic activity of Oldonyo in connection with large-scale animal migrations. The longest time they would spend actually in the Serengeti Plains, where they also give birth to their young. So there are thousands, hundreds of thousands of young wildebeest being born each year. This observation kind of triggers the thought that some of the regions in the Serengeti are better suited for a large number of wildebeest to stay for a long time than others. We've considered several factors that might influence this large-scale annual migration from a geological point of view, and Oldonyo stands out as one of the central geological features that controls this ecosystem dynamic. The volcanic ash has a very important meaning for the quality or the fertility of the soils in the Serengeti Plains. So what happens is that these very small ash particles are being deposited on the surface of the Serengeti Plains, and they will slowly get integrated in the soil. So that means that after some time, vegetation will start growing on these very young surfaces and will incorporate the minerals that this volcanic ash contains. It kind of just serves as a kind of nutrient engine of the wildebeest migration. The composition of the Oldonyo volcanic ash is of particular importance for the nutrition of wildebeest because it has a high amount of calcium in it. Also, the amounts of plant available or water soluble phosphate is very low in many soils in the East African Rift, but the soils that develop on ashes of Oldonyo have both high amounts of calcium and high amounts of plant available phosphate. So these two minerals are very important for a balanced nutrition of newborn wildebeest that need a lot of calcium and phosphate to develop strong bones or a strong skeleton. So it's kind of a wildebeest baby food that is provided in that region. And most of the time, wildebeest would suffer from a slight degree of undernutrition, and only when wildebeest would enter the Serengeti Plains, those nutrient levels would be high enough that no undernutrition would basically be detected. If activity of Oldonyo were to stop immediately, it would probably have a drastic impact on the soils of the Serengeti Plains. So what would probably happen over time is that the soil quality would gradually go down in the Serengeti Plains. Yeah, it would probably have a large impact on that wildebeest migration. Understanding the geological setting of an ecosystem might be extremely important to also understand the long-term stability of this ecosystem. So basically, if you think about shifting an ecosystem from the area where it's located right now to slightly to the north or slightly to the south, you wouldn't only change the climatic system or the maybe biological features, but you would also change the location of the ecosystem with respect to the underlying geology. And this might have drastic influences on the long-term stability of these patterns. Normally, volcanoes are known for their destructive force once an eruption starts. But one thing that particularly fascinates me is that these geological features have an extremely important beneficial meaning for ecosystems, for animal-landscape interactions, and nonetheless also for human-landscape interactions. So it's not only the destructive force of these geological processes that are fascinating to study, but it's especially the two sides of these processes that can either be destructive or beneficial.
Watch the sky.
2 meters. Oh my god.
Oh. Oh my goodness, 2 of them.
I haven't looked around.